Hi, today we're going to configure Routing Information Protocol version 2. As we start our video here, I'd like to discuss some points before we get into configuration. Here it says RIP version 2 is a classless distance vector routing protocol, meaning it depends on the count of hops or on the count of routers that it takes to get to the destination address. And being a classless routing protocol, it includes the subnet mask with the network address and its routing updates. That means if a port or if an interface is configured with an IP address, the subnet mask is internally known on the routing table. It will be advertised to the next routers or to the connected routers. It allows a maximum hop count of up to 15 routers. That means after 50, if we have 17 routers, we're not going to be using RIP version 2. We're going to need to be using another routing protocols such as OSPF, BGP, etc. Its administrative distance is 120. We're going to get into that in a bit. Let's go. To make this video shorter, I have already designed the network layout. As you can see here, this is a 172.16.10.0 network connected to the router interface gigabit 0/1. Let's go ahead and configure that. Can see here, you will figure terminal interface gigabit 0/1. We're going to give it an IP address of 172.16.10.1 and with the subnet mask of 255.255.255.0 since we have a /24 prefix, and we're going to type the no shutdown command to enable the interface. Okay, we're done for this one. Let's configure this here. Gigabit 0/0. Okay, interface. Gigabit 0/0. And we're going to give it the IP address 10.1.1.1. with the subnet mask 255.255.0, and we're going to type the no shutdown command. Okay, let's configure gigabit 0/2. Interface gigabit 0/2, and we're going to configure the IP address that is 10.4.4.2. So 255.255.0 says it /24 prefixes. Type the no shutdown command. Okay, we're done for router 1. Let's go to router 2 here. As you can see, router 2 is also connected to router 1 and router 3. Okay, enable configure terminal interface gigabit 0/0, and our IP address is 10.1.1.2 with the subnet mask 255.255.255.0, and we're going to type the no shutdown command to enable the interface. Okay, it's connected now. Okay, let's configure this interface here. Interface gigabit 0/1, IP address 10.2.2.2. Okay, let's configure the user side. Almost forgot. Okay, it's going to be the interface gigabit 0/2, and we're going to type the IP address, which is 192.168.50.1 with the subnet mask 255. shutdown command. Okay, we're done for router 1 and router 2. Let's go ahead to router 3. Router 3 is going to be, okay, enable, configure terminal, interface, gigabit 0/2, which is going to be this one here. And we're going to configure the IP address 10.4.4.1. 0. And we're going to type the no shutdown command. Okay, it's turned on. Okay, let's configure this interface here. Interface gigabit 0/1 with the IP address of 10.2.2.1. Of course, our subnet mask is /24. And we're going to type the no shutdown command. Okay. Let's configure the host side for the end user. And the IP address given to us is, the interface is gigabit 0/0. The IP address is 11.1.1.1. Again with the 255.255.255.0. That means that's /24. No shutdown. Okay. Now all the IP addresses have been configured on the interfaces. Let's go ahead and start our RIP protocol. On router 1, we're going to type router RIP, and then we're going to type version 2. Okay, what networks are attached to router 1? As you can see here, 172.16.10.0 is, and as you can see, 10.4.4.0 is, 10.1.1 is. So to advertise this network address, we're just going to type network 172, and I can leave it here. I can just say advertise any network with the starting number of 172. So bring it to gigabit interface 0/1. So I can just type 172.0.0.0 here. And we're going to go to the next one, network 10.0.0.0. Okay, that's it. It works for both of them, for interface 0/0 and interface 0/2, because they start with the 10 network address. Okay, as for router 1, we're done. Let's go to router 2. What networks are on router 2? Okay, let's check that out. As you can see, this is the 10 network. So, okay, let's start by router RIP. And we're gonna type version 2. And what network do we have here? Network 192.168.0.0. We're gonna do that. And we're gonna type again network.10.0.0.0. Okay, that's it. Exit. Okay, let's go to router 3. When we come to router 3, now we're gonna have a different network. Since, look at this, both router 2 and router 1 are connected to router 3 using the 10 network, but the host side have 11 networks, so we're going to advertise both of them. On our routing table, let's go router RIP and version 2. We're going to type the network 10.0.0.0. Okay, we're going to type the network 11.0.0.0. Looks like we're done. Okay, now to check the routing protocols, we're going to type, let's check out our router. Okay, exit. I would say do show IP route. Here you go. Okay, remember when we're talking about administrative distance here? It's 120 for RIP. So here it says now on router 1 is telling me that 10.2.2.2 is connected here through 10.1.1.2. 10.1.1.2 means this was here, router 2. So the administrative distance is 2 hops to get to the third router, and the administrative distance of RIP is 120 here. Okay, to talk about administrative distances, let me explain a little bit here. On Google, I have searched for administrative distances, and different routing protocols have different administrative distances. As you can see here, let's just see the image. Okay, as you can see here, for static routes, there's 1. For connected interfaces, there's 0. eIGRP have a summary route of 5. eBGP has 20. Internal eIGRP. eIGRP is a proprietary routing protocol for Cisco routers. IGRP have 100. OSP have a 110. So who do you think is more trustworthy when it comes to administrative distances? This shows us which routing protocol you trust more. As in this case, we're going to trust the connected interface than a router so many hops away from the interface. So connected interface, the lesser the number, the trustworthy the routing protocol is. That's what it means. Okay, let's go back to our config. Okay, now on router 1, look at this. RIP 120 is configured. Okay, router 1 knows about the 192.168.2. Look. So let's try to ping this computer here. The address is 25, so ping 192.168.50.25. Oh, destination host is unreachable because it's not advertised. To show IP interface brief. Every 192.168.50. Okay. So IP router RIP. There you go. So we'll try it again. Is router 2 advertising the 192.168.50 network? Is it really? We're pinging. Request is still timed out. It takes a little time to update routing tables, so maybe that's the case. Until then, let's check the routing table for router 1. Here you go. 192.168.50.0 via 10.1.1.2. So it should ping by now. Okay, let's ping the interface of the router. Okay, this is Let's just do a PDU request. Let's do it again. Okay, we're gonna need to do more advertising. Okay, router RIP version 2 network 172.16.10.0. Okay, network 10.1.1.0. okay, 10.4.4.0. okay, 10.1.1.0. 4.0. Okay, let's take our routing table here. Okay, we have successfully configured RIP version 2, and we can do PDUs from PC1 here to the PC connected to the router 3. Yes, it's a successful ping. Okay, we can do that from PC2 as well, from the computer connected to router 2 to the computer connected to router 1. It works successful. As you can see, as I've told you before, going back, we can say show IP route, and here you will see the administrative distance of 120, and all the connected networks, advertised networks, are in the routing table. So one router will get a routing table update from the next router, from the next home address router. So that's how it's done. I'd like to thank you for watching. I'll put the descriptions in the video below. Thank you for watching.